Alright, so I welcome you all to another session in DevOps. Today we are going to learn about um, classes in Python. Actually, we already did cover, but I'll make sure that we recover or refresh the stuff that we have just covered on classes. Then I will be talking of sets, which is the final iterable that we are supposed to be learning. Lambda functions in Python, what are they and when do we use it? File operations and context managers. Well, first let's review what we have seen about classes so far. So we had an editor, right? And we had created a few packages, right? There was a package that we created, a module that we created, and we imported that into example.py. We also have learned about uh, what inheritance is, okay, and how to use that. So how to build the classes, how to inherit one class into another one, simple inheritance, multi-level inheritance, multiple inheritance, all three of them. So let me give you a quick example. What we did actually, we created a class called pets like this, right? And it was inheriting from the object class, which is the default. Then we had a constructor. So I want my class to be initialized with name of the pet and the species of the pet. Say self.name equals to name and self.species equals to species. Then we had a very small method called getName. GetName would be responsible for returning back the name, right? Self.name. And similarly, we had getSpecies, which was responsible of returning the species. If you want to have a static class, then you'll have to add a decorator here which says static method. In that case, you will not have to pass the self parameter here, and you can call that method without even creating a instance of that particular class. Then we have seen about magic methods. Add str. So I'm using str here. We'll be returning a nice representation which says the name of that animal or pet is a particular species. And mod operator for specifying formats, self.name minus self dot comma self dot species. So that's the basic class that we did, and I've moved that into a pets.py file. Why we did that? Because we wanted to reuse it. So if I want to inherit it in some another class, I will be creating a class called dog, which I want to specialize. There are two ways of working with object-oriented programming. Either you specialize it or generalize it. Class pet is the result of generalization. The features that all the pets would be sharing, and these general features would be accommodated in a class. So this generalization process lead to creating the base class called pet. Now I want to specialize and add some more features to it. We have seen a feature yesterday that I want to separate out dogs and cats based on whether they are hating each other or not. So in the class dog, which inherits from the parent class pet, we would be having its own constructor, which would be taking in name of the dog and whether he hates the cats. And we would say call the parent class as constructor, right? Pass the parameter self, then it requires name, so I would be passing the name. It requires species, which is going to be hard coded for this class, and self dot hates cats equals to hates cats. Define another one that says hates cats. It would return either true or false, so I need it to be an instance variable. It should return self dot hates cats. Similarly, about class cat, it inherits from pet. I'm going to copy over this definition and use it as it is. Instead of hates cat, it is going to be hates dogs. The species is going to be cat. Now today we are going to look into that when we create instances. Okay, so once we create the instances, are these instances referred using the instance variable of the parent class? Would it work? Okay, so I just want to check whether it is an instance of that particular variable or not. Let me show it to you. If I create an object where my object D is created from a class dog, and dog accepts parameters, so I would say Crook is my dog's name, and it's true that my dog hates cats. Okay, so I want to check whether is instance, which is a function. So I want to check um, whether the D is actually an instance of type pet or not. And is it an instance of class dog or not. Similarly, I'm going to create a different object. Now this object is a similar one, and we're going to check whether P is now an instance of pet and P is now an instance of dog. Is instance P pet and P is instance of dog. Now each instance would give you either true or false based on uh, which object it's referring to. So let's see. I'm going to execute this. So it says it's true, 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 and false. So first print statement give me true. It gave me true because we can use the parent class references to point to the child class. Okay, so here the class is child class, but I'm checking whether it is an instance of the parent class. Yeah, because it is inherited from the parent class. So it says that it is the instance of parent class, and that's true. With the dog, it's blindfoldedly true. We have created the class object from the dog class itself. What about the next one? We have created the instance from the parent class. Your child class instances cannot point to the parent class instances, but the parent class instances can point to the child class instances. So vice versa is true. Here in case of P, checking that P is the instance of pet would be true because we have created it from the same class. But can P point to class dog? No, it cannot. Okay, you could go towards generalization, but you cannot go towards specializations using the primitive instances. We have also seen an example on multiple inheritance. So this example here is a simple inheritance. About multiple inheritance, we had created a small class. So I had a class called A. Then we had a class called B, and we wanted to have a class C which inherited from A and B both, right? We wrote attribute here in class A which is x equals to something, in class B where y equals to something else, and we tried to access both of them using the class C object. So in my case it is OB equals to class C, and we wanted to print whether OB.x exists and whether OB.y exists. So it says that it exists in either of the cases. But if the attribute gets overridden, in that case what happens? Always the preference is given to the left hand side class. So the value is 9 and not 6. So this was what we covered about inheritance in the sets class. Okay, and we have refreshed it. Now it's time to look into what sets have to offer. We have seen multiple iterables already. We have seen about lists, right? We have seen about dictionaries. We have seen about tuple. We have seen about string. Now it's time to look at what set has to offer. So set here is a mathematical term that represents unique elements, okay, any of the unique elements in that particular group. So if I write a list, let me open my Python block itself. Just for a while, I'm using that. Here it is. Okay, so let's say L is my list and L is holding some elements into it. 1 1 2 2 3 3 4 4. Okay, if I happen to save it and then check the length of list, it would give me 8. How long is my list? Containing 8 different elements. But if I want it to be a set, I don't want duplicate elements to be present inside the set anyhow, and there should be a check kept on it that would allow only the unique elements to be added. So let's do one thing. We are going to create a set like this where I'm going to define this. The set would be set up in a variable called s. Set is again defined by um, uh, this curly braces, okay, and in curly braces we are going to add our elements. So let's do one thing, add the elements in there. It's 1 1 1 2 2 3 3 4 4. Remember that curly braces were also used for defining the dictionaries, but here colon is not present. We haven't separated the keys and their values. So if you do this, S would be containing a tuple, okay, where the values are unique. We have defined it using 8 different values, 1 1 2 2 3 3 4 4, but eventually when we created a set out of it, we received just 4 different values. We can check whether the element is in a particular iterable or not using the in operator. So I could check whether 5 in S or 4 in S. Okay, so it would give me correct answer there. If my S1 is actually a string, I could use in and not in operators on this as well. So I could check if B in S1, so check and tell me whether it is present. It's false. If A is present in S1, it would say true. You could do it the either ways. You could check not in. Is B not in S1? It would say true in this case. Okay, we have just seen how to declare a set. We know that it is presenting us with the unique elements. What are the different methods that we could use on it? The different methods that we could use is add is one. Okay, then there is calculating the subset and superset of it, calculating the difference, um, removing the element, discarding the element of that particular set. Okay, so there are multiple. Let's try them up one by one. So here in my case, S is my set. I want to add an element to that. I would say S dot add, and I want to add an element which is 5, gets add. If I want to add it again, no problem with that, no error is thrown, but my set still would be containing just 5 elements. However, like regardless of how many times I add the same element to that particular set. Okay, other way of defining set is to write S equals to set itself, and that would be an empty set. Okay, remember that if you do S equals to curly braces, this is going to be a dictionary, this is not going to be a set. So S equals to set would be initializing an empty set for you. You can also generate a set from the list, just like typecasting. I have a list called 1 1 2 2 3 3 4 4. If I want to generate a set out of it, I would say S equals to set and pass a list to that function. So it would typecast that list and convert that into set. There we go. Now if I have two sets, now S is one of the set and S1 is going to be yet another. So S1 is another set which should be created from 1 2. Okay, so I've got two sets now, S and S1. For the operations that we perform in generally in maths, that we want to check whether set 1 is a subset of set or it is a superset of set. So let's see this. S1 dot is subset of S. It says true. Instead of subset, let's try with superset. Superset. Okay. That's a typo. Okay. So it says S1 is not a superset of S, but if I do it the other ways, S is a superset of S1. It says yes. Can we check the common elements in both the sets? For doing that, you need to use a method called intersection. It would give you the common elements which are present in both of them. If you want to merge both the sets together, then you would be using a method called union. So I would say S dot union with S1. Now since S1 is a subset of S, in that case the union would result in no different superset. It is going to be the same superset that we are having currently. Then there is subtract and difference methods that would be we would be performing. We could do something like this: S plus S1. Sorry, it's S minus S1, I guess. Plus doesn't work here. Yeah, so plus doesn't work. Instead of plus, we would be using union. Minus works, but instead of minus, we could use another method which is present there. We could use difference. So S dot difference S1 would generate the difference of it. Okay, the one that we calculated right now using the mathematical operator, we could also do it using a method. Now if you want to delete an element, there are two methods to delete it. One of them is called discard. Okay, I could easily discard an element from the set like this. If the element does not exist now, so let me show you the set again. This is my set. It has only 3 elements, not the fourth one. If I try to discard 4 again, it will generate no error. It wouldn't tell me that 4 does not exist. But instead of discard, If I use remove would give you an exception in case the element does not exist. With the elements which exist in in that set, in that case, it wouldn't give you any error. Okay, so these are the basic operations actually that you could perform mathematically. So there would be a set, there is a complex number data type here in Python. So these are the different things. They are not present with any other languages. That makes the life of mathematicians and scientific like scientists actually very easy. The next thing that we were supposed to be talking of is lambda functions. Well, what is a lambda function? We have seen about functions so far, right? No problem with that. But the lambda function here is a function that we can write in one single line. Many times we write something like this: def square, right? I would accept x, and I would simply return x raised to 2, right? Very simple function. And how do I use it? I would be using it like this: print square and the value. Well, these two lines that we have written, we could actually merge them into one. Okay, and that function that we are going to write, it's called a lambda function. So instead of defining the function like this, I'm going to define a function the other way around. I could say sq equals to lambda. You can pass as many variables you want to this lambda function, colon, and then the expression. In my case, I'm expecting just one variable, so I would write simply x. So if it is a arithmetic expression, one-liner arithmetic or algebraic expression, in that case you could use lambda functions for solving your requirements. So how do we use it? Remember that it is a one-liner function. You cannot have multiple lines in that. Now I can use print sq and pass some value to it, and that should give me the same answer. Okay, makes more sense here. um, Instead of defining the function in a completely different space and then using it, that's a one-liner function. You could simply use a lambda function to take care of it. Okay, it's very easy. You could also put it into algebraic expressions if you want to. You could pass it multiple values. Let's say if you want to have a plus b whole squared kind of formula, you could also do it using lambda. Okay, so that part becomes very easy. Important part of any programming language that um, relates to file operations, right? So we are going to look into file operations a little bit. What are file operations and how do we perform them here in Python? But before jumping to file operations, I wish to make my program a little bit more flexible. So why not to uh, accept some parameters from the command line? Okay, so for taking the parameters from command line, we need to do one thing. We need to include a package which is already present with the default Python. The package is called sys. So you have seen already how to take the input from the user, right? There are two methods, raw input and input. So I'll show you both of them, and then we would be dumping that content into a file. So let's do one thing. Import sys would import a package, and I'm going to use that sys package to check if there are any command line arguments passed to example.py. Print sys.argv, which is going to be a variable list that is passed to the script. Well, let's do only this part. Um, I would be passing some parameters, then you should be able to get the parameters here. Desktop, Python examples. Okay, there is example.py, right? So Python example.py, and then I'm passing a few parameters to it. Alpha, beta, gamma. So now you see that print sys.argv gave us some nice output. It is actually a list and list of parameters that we have passed to that particular file. Parameter 0 is the name of the file itself. Okay, that's default in any language. Parameter 0 is always the file that accepts the parameters, and then alpha, beta, gamma as the parameters that we have passed from the console. So what I want to do is I want to read some input from the user, and I want to store that into a nice file. Okay, the name of that file would be provided by the user itself. So let's say this is a program to store data about the user. So I would print something like this: print program for storing your data. Okay, no new line characters required. Here we are going to take input from the user. So I would say while it is infinite loop. Okay, so I want to loop out, I want to exit whenever the user types in exit as a word on the line. So I would keep taking the input here. So I would say the input which is coming in from the user is taken in by the function called raw input. I would say keep typing like this. So whatever the input user gives, we would be storing that into a variable called input. Now I want to dump it into a file. Okay, but before that we want to check whether the input is equals to exit. If it is equals to exit, then we will be terminating out of the loop. Otherwise this is going to be infinite loop. So I would say if my input is equals to exit, right? What if I want to check if the user types something like this, exit, it should still work, right? So what do I need to do here? I need to change the case. So whatever the string is, I'm going to call a method on it to lower. So it is going to convert that itself into lower, and it is going to check it against a string called exit. If this matches, then break out of the loop. And once it breaks off, we need to make sure that it dumps everything to the file, right? So there is going to be a file that we are going to operate with. So here we are going to open a file. Now the file would work in multiple modes. We could have a file opened in read mode, write mode, append mode, read binary, write binary, append binary, and so on. So there are multiple modes which are present. Now these modes can be provided to the open function. There are very less number of functions that provides you with basic file operation facility. One of the functions is called open, that helps you to open a file and return a pointer. So I would say my file, or just write f equals to open name of the file. So I want to create a name, a new file called out, right? And I want to use it in the write mode. If I open it in append mode, in that case any data that I want to write to it would be appended to it and not overwritten. So it's all up to you whether you want to open it up in the write mode or you want to open it up in the append mode. If you want to read and write simultaneously, you could go with W plus. If you want to read and write binary inside of it, you could go with WB. At the same time, if you want to append to it as well, you could go with WP plus. We are going to work with W for now. I'm just going to write inside the file. Okay, when we want to read out of that file, we would be using R. So I would say open the file out. So the file, if it does not exist, in that case it would be created, and now we are going to write to it. So the functions are very simple. For dumping the content inside the file, you would be using the method called write. For opening a file, you would be using a method called open. For closing the reference, you would be using the method called close. So let me write something to this file, f.write, and I'm going to write a string. Okay, but what is the string that we want to dump? We first need to store it inside some container, right? So let's do one thing. Either we store it inside a list, store all the input inside a list and then dump inside a file at once. So you could do it like this. Um, Here it is. You'll be creating a list called input strings. Okay, and then keep on appending the content to it. I would say input strings dot append. Keep on appending the input that we receive from the user every time. Alright, and then at last write to it. So I would say string input strings dot append, a new line character dot join. So it would be the list that we are passing to it would be joined by new line characters, and then write it to the file, then close the file. Let's see this. Then we are going to optimize this function even more. It says there's some problem with the while. Okay, I'll make it true. Remember that the true, false and none, if you are returning true, it should be capital T always. It is not small t. Remember that. For the false, it is capital F, and the null values in Python are called none, N-O-N-E, with N capital. It is not called null. It says EOF while reading a line. So what's wrong here? Line 7. Okay, let me run this from the console itself. Should work here, I guess. Yeah, that works. It says program for storing your data. My data is okay. This is my name. Store it, then let me type in some more words. Whatever I'm typing in here should go inside a file. If I type exit, it should terminate out. So if you see here, out file is created here, and all the data has been dumped to the out file. Okay, but the space requirement for this function that we have just created, it's huge. If I'm trying to write thousands of lines, it would first store all the 1,000 lines, and meanwhile if the program crashed, in that case all your data would be lost. Okay, we don't want that to happen, so I'm going to optimize this function a bit. Let's do it. Instead of writing it to the file at the very end, why not to write to it directly whenever the user types in something. So I would open the file before the loop, I would close the file after the loop, and instead of appending it to the list, I would be dumping it directly to the file. So I would say f.write, but this time I want to open the file in append mode. Since I want to add to it incrementally, I would say f.write, and what I want to write is INP. Remember to add a new line character. Raw input would give you the data back without a new line character, so you'll have to add new line character yourself. So I would say, yeah, so that's the new line character that I want to dump to the file. So this is more efficient function. um, we do not need any extra memory space. Let's do the same thing. So I'm adding some more words to be added to this out file and exit. Okay, so let's check what's the content of the out file now. It says some more words to be added to this out file. So it is trying to append to it. If I clear it up and try the program again, let's add some more words to this out file and exit. There are your words. When you call a program again, it would keep on appending to that list. So that's good. But can we optimize it even further? See that in Linux, the number of files that you could open at any given point in time are limited. By default, you could open only 1024 different files on that given operating system. And out of those 1024 files, lot many of the files are already open or kept open by the operating system for writing to the status files, writing to the pipes, and so on. So here, what I'm going to do is I'm going to get rid of the close statement. I don't want to be worried about writing the close statement. The reason is people generally open the file and they forget about closing it. So the file descriptors remain open for the time the program is executing, and that would retain or not release the resources which are supposed to be released in time. So the problem here is that the number of files which are open on the system gets blocked, and the legitimate requests are not successfully executed. For that, we are using context managers. So context managers um, is a construct which handles getting rid of the resource as soon as you are done with that. Okay, so here I'm going to use it. I would say with, so that is the keyword which starts the context manager, with open out a as f colon, and then the block that you want to work with that context manager, and you could easily get rid of f dot close now. Okay, so context managers work with file operations. They work with other parts as well, like in case of um, Mercurial. If you're writing a wrapper for Mercurial or Subversion, context managers would be available there. Context managers are also available with Fabric module in Python. Similarly, it is open with the file module here as well. So I don't need to call f.close now. I could easily work with it, and it would not cause any problem. Uh, okay. Another content added to the out file and exit out. Let's check the out file now. Another content added to the out file. That's how it is getting added. So this as well works. How to read from a file? For reading from a file, you need, let's say, currently this program is storing the data, but now we want a program to read from the file. Okay, so in order to read from the file, let's do one thing. I would say that it's a program reading from a file, and whatever the file name is. So %s would give me the file name sys.argv, We are going to use the first parameter as the file parameter. We are going to keep it dynamic. Okay, how to read it? Again, I'm using the same context manager so that I don't need to worry about the resource now. With open, what is the file name? It is sys.argv, the first argument which we are going to pass. Zeroth argument is the program name itself. So that's why. And I want to open it in read mode, not write mode this time. As f, remember that f will not be available outside the if with block in this case. And we want to do f dot read. F dot read would read the file at once. Okay, complete file at once as a complete block. It will not give you the results line by line. To generate the results line by line, you will have to use read line method. So let's first check this python example.py, and I want to read the out file. So this is the result of the out file. It says reading from a file colon out, and let's add some more words to this out file. Another content added to the out file. This is the content which was present inside the out file that we have just generated. If you want to make some optimum use of the space, then you could use read line. Okay, you don't have to use uh, read in that case. So read line would help you in reading one line at a time. So memory requirements are very less. You would be looping over the content and you would be printing it out. So how do we loop over it? I say while f dot read line, better I store it to something. Content or line equals to f dot read line. If not line, in that case break out of the loop. Okay, and we would say print line. So it is printing the lines, but this time you need to take care of the new line character as well, because print line, the print statement would be adding its own new line character to that block. So what I need to do is add a comma that should get rid of the extra new line character which is added automatically to the end, and this is how you would be getting the answer. But this program, even if it looks a few lines more bigger, it is more memory efficient than the previous one. It would work easily on any length of files that you would be having. Okay, so if something goes wrong, how do I handle these kind of situations? So in Python, we have got try and except kind of blocks. So that's called exception handling with Python. So we'll see a little exception handling here. That how do we handle the errors that we already know are going to occur in our program. Okay, for that to do, we would be placing this block inside a try and except section. You actually place a part which you think is problematic. So in my case, the open part is problematic. The file may or may not exist. The user may type the argument properly, or he may break it. So I'm going to add it inside try block. Try blocks help us to handle the errors. The program will not break like this by throwing a complete output. So if you are generating a nice utility and your users are using it, it would not look nice if you throw the errors back on their faces and say that this is the reason why my program is not working. Instead of that, you handle it gracefully and tell them that you have done some mistake, try to rectify it, and run the program again rather. Okay, so let's do that thing here. Try block would be checking for any of the errors, and except block, there is no catch block actually. Instead of catch, we are using except. So try something and accept the exception. So there is an exception class that you are going to declare here. Except block can be multiple. Different kind of errors are there. The error that we are getting here is IO error. So I can, instead of handling everything in the exception block, we could be more specific about the type of error that we are getting. And your except block can catch only that specific error. If you would like to catch everything, then the last block that you are going to write is going to be the exception block. I mean to say, the class exception should be mentioned because exception is the parent class of all the different errors which are being generated. Actually, the error would fall into 4 different categories, and most of them, almost 99% or more of them, would be falling in the class exception. So you can mention the parent classes of errors to handle the child classes, just like we have seen for each instance of kind of thing. So internally, each instance of is called here, and if the error is an instance of IO error, it would be taking the control inside this block. I would say, please, or I would simply say, unable to read from %s, whatever the file name is. Please check. Okay, I would say the file may not exist or permission denied. Right? Nice informative error for the user to debug the things. And %s has to be picked up from s dot sys dot argv and the first argument, like this. You could have actually throw your own exceptions as well. So I'll first cover this part and then I'll show you how to throw your own exception, because there might be a case where user fails to pass the parameter itself. So your first argument is argument does not exist. In that case, there would be no error thrown, but the error would be thrown here um, on this line itself, because the argument is not present and the error would be key error. Key 1 does not exist in that particular list. But we don't want that to happen because the user wouldn't know what's wrong. So in order to catch that error properly and to give our own custom message, we would be throwing our own error. Okay, so let me show you how to do that. Sorry about the interruption, people. So I was talking about the arguments. If it is not passed, we would like to catch it all by ourselves. So in current situation, let's try whether the try except block would work, and then we would be throwing the exceptions ourselves. So this is where I'm going to execute it. Okay, let's execute example.py, execute out. That works. What about out1? It says reading from a file out1, unable to read from out1, the file may not exist or permission denied. This is how you elegantly capture your error and give the user a proper output. Okay, I can now try to handle the error which does not exist even. The error might be if the user is not passing any arguments. So I would say if length of my sys.argv is equals to 1, that means it contains only one single uh, entry, which is the file itself, and the first argument is not passed. Or in case we are accepting only one argument but the user is typing two arguments, in that case what to do? In that case also we could check here if length is not equals to 2 very specifically, it could be less, it could be more. In that case we could say throw, sorry, not throw, it is raise exception, or not implemented exception. So I would say we have not implemented this kind of functionality yet, so I would not implemented. But not implemented what? So the message is supposed to be improper argument list. But whenever you raise an argument, raise an error or exception, you need to make sure that you catch it. If you don't catch it, the program would still break. So let's pass two arguments this time. It says raise not implemented improper argument list, type error, not implemented type, and it broke off. Let me check here what's wrong. So we are raising an exception here for particular type, and let me check if it is not implemented. Mm, not implemented error. Okay, so that's the class name actually. I missed the class name. So we are raising the not implemented error here and would pass the message like this. Let's try to execute the program again. Okay, so it has generated an error here which is not implemented error, and we have not um, catched it. Okay, we haven't implemented that error yet. It is simply thrown on screen and the program breaks. But I don't want the program to break yet. I want to catch it inside a nice except block. So what I would say is I would add it into a try block like this. So my try block my try block now increases its scope. First we were just having a try block across the open statement. Now we are having a try block for all our conditions. It is raising not implemented error. Now we could be doing two things. Either I want to be very specific about the errors that I'm catching. So I would say accept not implemented error. Okay, and print the whatever is coming in inside that object. Or I could simply say accept exception, whatever kind of exception it is, and print that exception. It would work either ways, but the good idea is to always be more specific about the errors so that you can test your program very robustly. Anytime it breaks, that means there is an error that you haven't handled. Okay, it's line number 15, some indentation problem. Yeah. There it is. So it has given us a nice output which says improper argument list when we pass more than one arguments, or do not pass the argument at all. If you pass the argument, that should work properly. If you pass argument that does not exist, it would give you another error. So this is how you make your program more generic and more open to failing. So if you want to fail fast, provide user with a nice output so that the users are not lost, and they would not blame your program for any of their own problems. Maybe the file does not exist, but your program simply breaks without telling that the file does not exist. In that case, there is no way for the user to know that there is a problem on his side and not on the program side, right? So this is an example of try and except block. If none of the exceptions occur, there is this yet another which is called else block that you can add with the try except. I would print no exceptions occurred. So if it is unable to execute or unable to read, in that case, no exceptions occurred is not printed. But if the program is successful and none of the exceptions were occurred, it says no exceptions occurred, it jumps to the else block. All right. So this is how you catch the errors. So we have seen about file handling, we have seen about catching the errors, reading from files, implementing read line, dumping to the files. Let's do some basic operations at the directory level. Okay, so what if uh, you want to maybe check whether a file exists on that particular directory or not. So there is another module called OS. Okay, this operating system module would help you in doing some very basic operations on the file, like renaming a file, or deleting a file, or deleting a directory, creating a directory, and all those kind of routine stuff that anyone wants to do. Okay, so let's do one thing. We would be using OS module for renaming a file that we have just created. Okay, so this program is a simple program actually. We haven't done anything fancy here. Just try catch block and trying to make the program more generic by adding context managers and different kinds of exceptions which are there, accepting the parameters from the command line arguments instead of uh, passing it ourselves, okay, or hard coding it. In the earlier example, we have seen how to dump the content to the file by making more efficient use of memory. So all the programs that we have written it first time in a very crude way, and then we have optimized them to perform well under high loads. So here, another program that I want to show you is to rename the file that we have just written. And everything from this point onwards in Python is going to be either one of the modules that the people have created for you. Okay, basics of Python are limited to this. You would be using that in various different combinations and scenarios, and using the modules what people have already given us to use. So now I would be importing a module called OS, which is responsible for some operating system level file operations. So I would say os.rename. The old file is the out file. Okay, and I want to rename that to output. Let's execute this. It says finished in 0.1 seconds, and the out file is now renamed to output. If you see here on the left hand side, it is now the output. If I do it the other ways and rename output to out, the listing here which says output on the left hand side column, it should convert to out. That's out again. Well, we could also remove the file. The method is remove. There would be multiple methods, right? You'll have to check the documentation for getting various methods in here. There are hundreds of methods that you could call on the operating system module. For removing it, you could simply write the name of the file that you want to delete, and the file would be deleted. It's off. It does not exist here in the left side now. You could do the same things with directory, but the remove wouldn't work there. In that case, you'll have to use rmdir, okay, or remove directory, rmdir. That's in case of the directories. You could make the directory or change the working directory like this. mkdir would make the directory. Changing the current working directory, chdir would be changing the current directory to another location, and so on. So multiple methods present there. How to check the documentation? Open up your browser, um, and there is a website called docs.python.org. Here it is. Okay, we are looking for Python version 2.7, so you could choose it from this drop down, and this is the documentation. You could search from here. Okay, so we were talking about OS, right? OS. So it says OS is a Python module. So let's check it. Click on it. It would give you a nice documentation about all the different methods which are available. We have seen about chdir, get, not get, change the current directory. There would be multiple ones like gids, groups, and so on. Rename would also be present here. Remove is present. Rename is present, and more of them. Right? There are hundreds of different methods that you could actually call on that OS module. And we would not be able to get through all of these. This documentation is an extensive documentation for all the modules which are present in Python, rather all the modules which ship with Python, the default modules that ship with Python. You could also check for the exceptions. Exceptions, it is exception, I guess, not exceptions. Yeah, so there is a Python module called exceptions as well. If you want to check for a specific class, let's check for exception. It would be present in exceptions module itself. Yeah, so the class name is exception, and there would be different errors which are related to that. IO error is a child class of exception. We have seen IO error, right? Another one that we have seen is not implemented. Then there is key errors. Okay, one last statement that I want to show you that we haven't used yet. It's called assert, and we use assert for checking whether the value that we are expecting out of that function or a variable is matching the one that we are supposed to be using. So this is just like writing a test case. So I would say, let's say x equals to 5, and I would say assert x equals to 5. I'm going to check whether x is equals to 5. Okay, if that works, nothing would be thrown out. If it is false, then it would give me an error. And let's print it out. Okay, let me check the syntax here. That should be the same syntax. Assert x equals to 5 or give me an error, right? If x is not equals to 5 in that case, then what? Okay, then it would give us an assertion error, and the error would be the one which is mentioned here. So if I say error x should be 5, okay, and I execute this, it says assertion error x should be 5. So what I could do is I could have a function which calculates square. Okay, so there is a function which calculates square for me. I pass it x, and it should give me back x raised to power 2. So how do I check the validity of this function, whether this function is actually working or not? So let's try a few things. If I call sqr on 0, it should give us 0. Okay, so we say result or something like this, sqr of, this is the way your testers would be writing the test cases. Sqr 0 should be 0. So before even writing the function, they would be writing the test cases for you, and based on those test cases you would be coding your program. So I would say sqr of 2 should be 4, and sqr of 4 should be 16, and pass the values accordingly. If this works, error should not be generated. Let's try. It says no errors. Okay, but there is no information about how many assert statements were actually executed, right? So we don't have any information about how many assert statements are there. That means how many test cases we have passed, how many of them are failed to handle the assertion errors properly. If it doesn't pass, it is simply going to throw out an error that we are not able to handle currently, or we would be handling it. We will have to try and catch block for that. So for handling all of these, there is a nice library which is present in Python. That library is called unit test. Okay, I'll show you a few methods from unit test, and one of the methods of writing a project or creating a project, which is called TDD, test driven development. Okay, we'll see a small example of how test driven development would work. So here what I want is, I want to write a program for factorial. Okay, so I don't know the logic for that. My tester has given me a ticket that you need to write a feature for calculating factorial of the numbers, and I've got the input, and this should be the output. So if the input is 2, I should be getting 2. If the input is 3, I should be getting 6. If the input is 4, I should be getting 24. So this is the input and output test cases that my tester has given me. Or even better, he gives me just the requirements and I write my own test cases. So unit test cases are written by the developers themselves. So this file here, which I'm going to create, I'm going to write it, save it as my factorial tests.py. Very first we start with tests. We do not write the code yet. And I would be creating another file that would be holding my code, and let's call that file as factorial.py. Okay, so we don't write the code yet. We start with factorial tests.py. So how to work with that? Very first thing is, you need to import the unit test. And unit test module is import unit test. So this is what the module name is, and we would be writing a few tests now, like this. Class factorial test, right, inherits from unit test dot test case. So this is the class that I'm going to set up, and I'm going to fire the test cases. There are different methods actually that helps you in creating the variables, loading the files, anything that you want to do before running the test case. The method is def setup. It would be expecting the self. And then you could call in any of the methods and set the variables here, the instance of variables rather. Okay, but in our very simple example factorial, we don't need setup to be working, so I could get rid of it. I could directly write the test cases. The test cases methods should always start with a keyword called test. So I would say test no factorial value. So that is the name of my test case. So I want to check if no factorial value is passed, what happens. Okay, so that's my first test case. I would be calling the assertion like this: self dot assert equal, that is a method in unit.testCase class. And what do we want to check? We want to check whether the file in which our method is called, so the method is called in factorials.py, right? So the file name is factorial.py. So I would say factorial.py, not .py, fact. So that's the method name that I'm going to call. Or even simpler, we could say from factorial import fact. So factorial is going to be my file and fact is going to be the method inside of it. So I would call it directly like fact of 0 should give me 0. That's my first test case. I have to check a few more test cases. So fact of -1 should give me 0 again. Sorry, factorial of 0 is 1, right? Factorial of -1 does not exist, so it should give us 0 directly. What about factorial of 1? It should give us 1 back. So no factorial value, let's write just these two test cases. I would be writing another test case here, that test same value factorial. So in this test case of mine, same value factorial, I would be writing fact 1 should give me 1 and fact 2 should give me 2. Now we are calculating the factorial for test higher order numbers. Okay, so for higher order numbers, we want to check whether the factorial of 3 gives us 6. We want to check whether the factorial of 4 gives us 24 and whether factorial of 5 would give us what is factorial of 5? It's 120, right? Whether it gives us 120 or so. So as our program would evolve, we would keep on writing the test cases first. Okay, how to execute the test cases? I would say if the name of the starting block of the program is this file itself, okay, which is referred to as main. Any starting point of the program is referred to as main itself. If it is main, then execute the class. So I would say unit test dot main has to be executed in that case. Otherwise, the execution would not happen and we would simply be able to include that file into some another program. So let's try this out. I'm going to execute this. It says cannot import name fact because fact does not exist. So let's keep on fixing the errors, okay, and that would lead us to our that would lead us to a solution that is required by that particular person. So it says cannot import file name fact, so fact does not exist. Open up the factorial, define fact as a method which accepts x, and it would give you back a factorial. Okay, what is the method to calculate a factorial? Very first, let's put in an empty method. We are not worried about the logic yet. Execute this. It says ran 3 tests in 0.002 seconds. What is the result of the tests? Alright, the first test failed. It says higher order numbers actually failed. Assertion error was generated. We expected 6 but we received none. Similarly, with no factorial value, we expected 1 but we received none, and so on. So I need to fix the bugs here. So let's do it one at a time. Very first, test for no factorial values. So if it is 0 or -1, it should be generating, for -1 it is 0, for anything less than 2 it is the number itself, correct? For 0 it is 1. So let's do that, implement that particular part. So I would say if x is less than 2, less than or equals to 2, then do one thing, again check if x is greater than 0. If that is true, then return x as it is, else x, if x is greater than 0, return x. If x is less than 0 or equals to 0, in that case what should we do, we should be doing? Should be checking that if x equals to 0, in that case return 1. Now we are pretty much sure that the third condition which is left is less than. If x is less than 0, in that case return -1, sorry, return 0. So that's the basic logic. We are still not calculating the factorial. Let's try out the tests. Executing the tests, it says ran 3 tests but failed just 1. So 2 test cases passed because of that logic. Okay, 2 test cases which passed were the first one, no factorial value, and the same factorial value. Now the higher order numbers have to yet to be calculated. So for generating these numbers, we need to write some logic inside the function, some actual logic. The factorial is actually returned like this. Factorial of x is x multiplied by factorial of x minus 1, right? So if that would work, let's check what the results are. It says ran 3 test cases successfully and everything works. So now these test cases that we have written, we could automate that using Jenkins. So you all are aware about Jenkins, right? So if you call this script in Jenkins and give it a shot, maybe in your build.xml, you create an exec block to execute this script directly, then you can check whether the code is working as per expectations or not. If anything goes wrong, in that case, you would be breaking off the job. You would simply stop there, throw the error, notify the person who's responsible for that. Okay, that's how it works in real life. And the way that we used for creating the program, it's called TDD. It is called test driven development. Test cases first. So this ensures that each and every line of our code is having a test case associated with that, and we would be achieving almost 100% of the test coverage. That should guarantee that we are able to deploy the code automatically. So the release pipeline that you are building will not be dependable on manual testing for that reason. Everything should be tested automatically in that case. All right, so that's all about the Python stuff that I wanted to cover, okay, or anyone would be covering. The next part here that we are going to touch in the coming classes is going to be bash scripting. Okay, so bash has its own flavors and features which are there. It works very closely with file operations. Anything that you could do on Linux by typing commands, you could automate that using a script, and that script is called bash scripting. So I will show you how to work with pipes, how to work with different file descriptors, how to loop, how to work with uh, the input parameters which are coming in from the script, okay, defining variables, control structures, and all those different kind of things in bash scripting. We would meet again on Monday, Okay, so if you have any queries or doubts, feel free to ask it now. Since you have a weekend ahead, you should be able to practice all of the stuff that we have covered so far. After Bash, we would be jumping to a new topic. Okay, so that is going to be a new module altogether. Um, and it's going to be about Docker. So understanding containers, working with containers and Docker is what we are going to cover next after Bash. Any queries or doubts that you want to ask? Anything that you might have practiced and you want to raise a query here? Okay, so if there are no queries, I would drop off the call for today. We would meet again on Monday at the same time with a new topic, which is Bash scripting. All right, get yourself acquainted with Linux basics. So that is a prerequisite for Bash. Thank you so much for attending the class today and have a great weekend ahead. I'll meet you on Monday.